This lesson is going to consolidate the learning that you've done over the last couple of lessons on uses of the Moivres theorem. So there were two separate lessons that you've already done. The first one was writing sine n theta or cos n theta in terms of powers of sine or cos. And if you remember when you did that, what you would then do is go on and use that form to solve a polynomial equation, giving your answers in exact trig form, which is really useful. Then the second lesson was expressing powers of sine and cos in terms of multiple angles. And if you remember, the application of that was to be able to integrate powers of sine and cos using that multiple angle form. Okay, so quick reminder of how you went about doing this. So if you wanted to express sine n theta or cos n theta of powers of sine or cos, what you did was you did a binomial expansion of c plus is. Now remember what c plus is is. C plus is was cos theta plus I sine theta. And remember, by de Moivre, if you raise that to the power of n, that gave you cos n theta plus I sine n theta. Okay, so then if you were interested in the cos part, you would take the real part of that. And if you were interested in the sine part, you would take the imaginary part of it. Okay, so binomial expansion. And then the application, as I said, was to solve polynomial equations, but giving your answers in exact trig form. Right, so let's crack on with an example. So you probably want to pause this to write down the question. Typically, these de Moivre theorem questions look like this. They're made up of two parts. First part is show that, and then a second part will be using the show that. Do remember in exam questions, if you see the word hence, you have to use part A. All right, so even if this was an equation that you could put into your calculator, that wouldn't be valid because of that word hence. Okay, so for part A, what we're going to do then, cos 5 theta, we're going to expand c plus is to the power 5, okay, because remember that gives us cos 5 theta plus I sine 5 theta, and we can pick the real part. Right, binomial expansion. So let me show you what I write out for the binomial expansion. You picture you've got 5 brackets that you're expanding. So the first term is going to be that I have picked 5 of these, so c to the power 5. There's only one way of doing that. My next term, now it's all about how many different combinations I have for picking. I want to now pick 4 c's and 1 is. So the number of ways I can do that is 5, choose 1. Okay, c to the power 4, is to the power 1. Now notice, hopefully you know this number here is how many I've got of these, so it's to the power 1. So to get the next term then, we're now going to do 5, choose 2. My powers of c go down 1, my powers of is go up 1. Notice the 2 at the bottom, 5, choose 2, is the power of the is. Is in a bracket because I is raised to the power as well. Okay, 5, choose 3, c squared, is cubed. Okay, 5, choose 4, c cubed, sorry, that's not c cubed. That's wrong. So the power of c goes down by 1. So that's just going to give me 1 of those and 4 of those. And then my last term, 5, choose 5 is 1. And what I'm doing is I'm picking 5 of these. So write out your working like that, because that gives you a mark for a successful binomial expansion. And then go on and simplify the terms. Right, c to the 5, I'm leaving a c to the 5. Use your calculator if you don't know what 5 choose 1 is. It's equal to 5, so I get plus 5, c4, s, and I'm going to put the I at the end because in a moment I'm going to be picking the real and imaginary bits, and so I need to know which bit is real and which bit is imaginary. Next term, I'm doing is all squared. Remember, I squared is minus 1. 5, choose 2 in your calculator is 10. So I get c cubed s squared. Okay, now I'm doing I cubed. Just a little aside, if you don't remember the powers of i's, you can write them out to help you. It goes I squared is minus 1, I cubed is minus I, and I to the 4 is 1, and then it cycles round again. Okay, so I cubed is minus I. Okay, 5 choose 3 is 10, so I get c squared s cubed I. Okay, 5 choose 4 is 5, I to the power 4 is 1, so I get plus 5 cs to the 4. Okay, and then my last term, I get s to the 5 and I to the power 5 is I. So I'm interested in the cos bit. So cos 5 theta is going to be the real part of my c plus is to the 5. So picking out the real parts then, they're the parts that haven't got an I. So it's that part, it's that part, and it's that part. It's always the alternating terms. So I've got c to the 5 minus 10c cubed s squared, that's the cubed, plus 5 cs to the 4. Now that is my answer, but look at what we're trying to show. We're doing it all in terms of powers of cos. So I now need to use my identity, that is sine squared theta is 1 minus cos squared theta. Okay, so that stays the same. So I'm going to replace this s squared with 1 minus c squared. And s to the 4 is 1 minus c squared all squared. It is a show that, so make sure you're nice and convincing that you do get the final answer. So I just expand out that bracket. And then I'm going to expand this out. It's 1 minus 2c squared plus c to the 4. And then just double check that you get what you want. You want 16 cos to the 5. I've got 1 there, 10 there, and then I've got plus another 5 there. So I do get 16c to the 5. Just double check it works. 20c cubed. I've got minus 10, minus 10, minus 20. And then I get plus 5c. I can leave my answer like that as long as I say where c equals cos theta. You must say that at the end though if you're going to leave it like that, or rewrite it out as the answer that you want. So that's your 5 marks, and that's all the working to show to get those marks. Okay, let's go on to part B then. You'll see part B is worth as much as part A, and it's going on and using the De Moivre identity that you've proved there to solve this equation. Now the equation will always relate to the identity that you've shown. It will have a different letter in. So what I'm going to do first, you can see within my equation I've got 16 cos 5 theta. Within my solution of my equation I'm solving, I've got 16 x to the 5. So x is actually going to be equal to or equivalent to cos theta. Now this is a really useful thing for you to write, because you have to make sure that you remember at the end, once you've solved for theta, you've got to remember that that's not your answers. Your answers are x equals cos theta. So I'm going to rewrite my part A. So cos 5 theta with cos theta replaced by x. 16x to the 5 minus 20x cubed plus 5x. I want to make it look like the one I'm solving. So the one I'm solving has got a plus 1 in it. So let's do a plus 1 in it. So cos 5 theta plus 1 equals 16x to the 5 minus 20x cubed plus 5x plus 1. So because I'm solving this equals 0, that's going to be equivalent to solving cos 5 theta plus 1 equals 0. So you can see how I've equated solving the polynomial to solving something to do with that cos 5 theta, and they'll always end up like this. Right, so let's solve that trig style then. Okay, so that's the same as cos 5 theta is minus 1. Now the thing I'm solving, it's a quintic, so I'm expecting 5 answers. So my calculator will give me 1, 5 theta equals pi. I want to get 5 in total. How do I get more answers? I add 2 pi to them. 3 pi, 5 pi, 7 pi, 9 pi. Okay. Values for theta, pi over 5, 3 pi over 5, pi, 7 pi over 5, and 9 pi over 5. Now here's the point in time where if you hadn't written this bit at the beginning, you might well think your job is done. It is not, because these are answers for theta, not answers for x. So I have to put them back in, all right, to get my answers for x, because the equation I'm solving is in terms of x, not theta. So x equals cos pi by 5. Now if it was me, that is a nice exact value and I would leave it like that. But the examiner has said he wants 3 decimal places, so let's give him what he wants. Okay, often they will say leave them in exact form. So I'm going to do that for each of them. Use my calculator, make sure it's in radians. Okay, cos pi is -1, cos 7 pi by 5, and funny enough, when you put that in your calculator, what you'll notice is that is the same as that answer. So we have some repeated roots here. Okay. All right, so these are my answers. 5 of them, but 2 of them are repeated. Okay, so that I would say with these questions is the really important thing to remember, that you will solve the polynomial, you will relate it back to the thing that you have proved, but do remember this, that basically you've substituted the variable within the equation, you've related it to cos theta, so you can relate it back to the identity that you've just proved. So your answers, and most of the time actually questions will say leave it in exact form, so you get answers to that polynomial as trig functions in exact form, which is really neat. Right, got one more of those to look at, and the reason I've done this one is it's a tan one. So hopefully you'll remember how to do the tan one. Remember, tan 4 theta is sine 4 theta over cos 4 theta. So I'm going to be, for that part, I'm going to be expanding c plus is to the 4. So while I'm doing it, why don't you do it alongside? C to the 4, 4 choose 1, c cubed is, 4 choose 2, c squared is squared, 4 choose 3, 1c, 3 of those, and then the last term is, sorry, the writing's a bit messy there, the last term is 4 of those. C to the 4, 4 choose 1 is 4, so 4c cubed si. Okay, 4 choose 2 is 6, but I squared is -1, so I get a -6 c squared s squared. 4 choose 3 is 4, but I've got I cubed, so remember I cubed is -I, so I get -4 c s cubed I, and then the last one's going to give me plus s to the 4. Okay, so I want to do tan. All right, so tan is sine over cos, so let's write out the sine 4 theta bit first. That's the imaginary part of c plus is to the 4. So the bits with the i's in, 4c cubed, whoops, 4c cubed s minus 4cs cubed, and cos 4 theta is the real part. Okay, and the real part is the c to the 4 minus 6 c squared s squared and plus s to the 4. So now I'm going to form my tan 4 theta, which is sine over cos. As I'm writing this, do you remember how to change those into tans? Okay, You can look at your answer to help you, so the thing that you're trying to prove. What you do to change those into tans is you divide top and bottom by the highest power of cos, so by cos to the 4. And what that gives you then, this one here would give you 4, you end up with an s over c, so you get 4t. This one would give you s cubed over c cubed, so 4t cubed. That would give you 1. That would give you a t squared, and that would give you a t to the 4. So that is your final answer. Write it out again, or I'm just going to say where t equals tan theta. Okay, so remember with the tan theta, tan 4 thetas, you need the sine bit and the cos bit, which you then write over each other and then divide through. Okay, that's 4 marks. Let's go to the second part, which is even more marks. So again, what I said to you is we're going to relate that equation to this identity. So you can see the equation has t's in, and I'm going to let t equal tan theta. Okay, so let's rewrite my identity. Tan 4 theta equals 4t minus 4t cubed over 1 minus 6t squared plus t to the 4. The thing I'm solving doesn't have any fractions in it, so let's multiply up by the denominator, okay, and I get tan 4 theta times, I'm just going to reorder these, t to the 4 minus 6t squared plus 1. Now you can see in the equation I'm solving, it's just got a t to the 4 here, so I'm going to divide through by this. So they're going to end up just like that, and these are going to be over that. Okay. So what I'm trying to do is make it look like the thing I'm trying to solve. So let's pop it all on one side and let's just order the terms so that they're in the same order. Just notice I've missed a 4 there. That's got a 4 there. Okay, minus 6t squared minus 4t over tan 4 theta plus 1 equals 0. So you should now be able to compare that with this and work out what value of tan 4 theta we need. What's the answer? Tan 4 theta equals 1 over root 3. Okay, you'll see how that then gives you that equation. Right, so I'm solving that. Quartic, so I need 4 answers. So one answer using your calculator. 4 theta is pi by 6. Cast diagram. Okay, so there's my pi by 6. My other one's here, so 7 pi by 6. I want 4 answers, so if I add 2 pi to each of those, I'll get 2 more. Okay, so that's my 4 answers I want. Theta then, if I divide by 4, pi over 24, 7 pi over 24, 13 pi over 24, 19 pi over 24. Here's the bit to remember, they aren't my answers, t is tan theta. So my final answers written in exact form, can you see, exact roots are t equals tan pi by 24, t equals tan 7 pi by 24, t equals tan 13 pi by 24, and t equals tan 19 pi by 24. I think that's really neat to be able to solve a quartic equation like that, giving your answers in exact form using trig functions. I do think that's quite cool. Okay, so that's the second one of those done. So let's have a look now at the second type of questions that you get. So this is where you do powers of sine and cos in terms of multiple angles, and the application of those is to enable you to integrate powers of sine and cos. Remember why this works. It's making use of de Moivre again. Z is cos theta plus I sine theta. So by de Moivre, 1 over z is that to the power minus 1, or cos theta minus I sine theta. So when you add them together, you get 2 cos theta. When you subtract them, you get 2i sine theta. These are important, the 2 and the 2i. You've got to be really careful to make sure you remember them. So if in a question I want to say do cos to the power 5 theta, what I will do is I will do that to the power 5 and then another binomial expansion for that. Okay, these we then use once we've done our expansion to convert back into our multiple angles. So let's have a look. We've got one example of those. Here we go. Another show that. Okay, show that sine to the 5 theta is equal to that. And then here's the application of integration. So when I do these questions, you want to make sure you remember that the z minus 1 over z is equal to 2i sine theta. So before I do the expansion, I will put it equal to that, and that will make sure that I remember that I've got the 2 and the I, what did I write here? I've got the 2 and the I floating around as well, because although it's a show that, you have got to be nice and convincing that you have done the proper answer. There we go, that to the power 5. I'm just going to say what z is equal to, okay, because I've introduced a variable into my question, so I need to state what that variable means. Right, binomial, we're good at these now. Z to the 5, choose 1, 4 of these, in a bracket 1 of these. Okay, 5 choose 2, 3 of these, 2 of these, minus as well. 5 choose 3, 2 of these, 3 of these. 2 more terms, 5 choose 4, 1 of these, 4 of these, and then the last term, I don't need to write my 5 choose 5 because that's equal to 1. Okay, let's tidy these a little bit. I've got a z to the 5. I've got a minus 5 choose 1, use your calculator if not sure, 5z cubed. 5 choose 2 is 10 plus 10z squared. 5 choose 3, okay, is 5. Okay, so no, it's not, it's 10. And that's going to be minus, okay, and I'm going to have 10 times 1 over z. Okay, that's not z squared, is it? No. Silly me, that's not z squared. Let's get rid of that one. Let's just check that term there. Z cubed times 1 over z squared. That just gives me z. Okay. 5 choose 4 is 5. So I get plus 5. And what have I got? 1 over z cubed. And then my last term, minus 1 over z to the 5. Now what you'll notice is you always get z to the power somethings and 1 over z to the power somethings. The only thing you need to check is whether they've got a plus or a minus in between them. So what I do is going to group them. So I've got z to the 5 minus 1 over z to the 5. Okay, if I take out a minus 5, I've got z cubed minus 1 over z cubed. You happy with that? Because I've taken out the minus. And then if I do plus 10, I've got z minus 1 over z. Okay, so we can now replace these back with what we had on the previous slide. So again, using de Moivre, that's equal to 2i sine 5 theta. Do not forget the 2 and the I. Okay, that's equal to 2i sine 3 theta, and that's equal to 2i sine theta. So if I translate down, that whole thing was equal to, in a bracket, 2i sine theta to the power of 5. So that's equal to 32i sine 5 theta. Okay, so you can see how it's useful to have that written so you can then translate it down. All of the i's will cancel. I can divide by 32. Each of these have got a 2 in, so I'll end up with a 1/16. And I can pretty much, because it's a show that, write down the show that and double check that it works with my working. If it doesn't, go and find where you've made a mistake. Okay, if it does, then you've shown all of the working you need. Okay, don't need that bracket there. And then the last bit, 10 sine theta. So examiners are really good at spotting you trying to fudge things in answers. So if you do get to the bottom and something's not right, you may well have forgotten this 2i bit, or you may well have forgotten when you substitute these back in, the 2i bits here. So go and have a look, and they will knock marks off if you don't show it nice and clearly. Right, let's go on to our application for it then. Hence or otherwise. So for this one, they're saying you can use part A, or you can do it in a different way if you'd like to. The hence is always the easiest way. Okay, so what I'm going to do is I'm going to replace my sine 5 theta with what I've got in the first part. I'm going to stick my 1/16 outside, just keeps it a bit tidier. And it is a constant, doesn't matter, you can put it in if you want. Okay, so that's equivalent to that. Remember your d theta, 1/16. Now, you've not done a lot of trig integration, but it's reverse of differentiation. Okay, so sine goes to minus cos, so you get minus cos 5 theta. Remember, with differentiation, you times by 5, so with integration, you divide by 5. So that's 5 cos 3 theta over 3, minus 10 cos theta. So you're applying your limits mark here, okay, and you get minus cos 5 pi over 2 over 5 plus 5 cos 3 pi over 2 over 3 minus 10 cos pi by 2. And remember, when you have a limit of 0, I know sometimes it gives you 0, but cos doesn't, because cos of 0 is 1. So you get minus 1 over 5 plus 5 over 3 and minus 10. Now, if you put these in your calculator, you'll actually find that that's 0, that's 0, that's 0. So all you end up with is 1/16 times that. It is a show that, but do just put it in your calculator to double check, all right? Because you may have made a mistake somewhere, and if it doesn't equal that 8/15, go and find your mistake, because if you don't, the examiner will. So here are the questions I'd like you to do. They're from mixed exercise 1. They're all exam questions. I have a few parts to them, and they are quite tricky. So do make sure you work through these carefully. Use my examples to help. Show all of your working nice and clearly. And I'd like these submitted on Teams, please, by Thursday, the 4th of June. Good luck with those.